Hey guys, we're gonna kind of do something a little different today. We're gonna play with electricity, which is a dangerous thing for me, as most of you know, because if you follow this channel, you know that electricity is definitely not my strongest suit. I certainly know enough to get around and solve pretty much any electrical problem, but it doesn't come very easily for me. And the thing is, I happen to know that this is the case for most of you as well. Most of you are pretty much in the same boat I am, where you know how to use a voltmeter to look at voltage and amperage and things like that. You would know how to put 12 volts to different components to test to see if motors work or lights work, things like that. You probably even know how to test a relay outside of the car. But the idea of maybe using a jumper wire in the actual relay outlet in the car, or putting 12 volts to one of those contacts in the car to test components might be a little bit out of your comfort zone. And that's kind of what we're going to get at today, is doing a little bit more of an advanced relay testing, other than, of course, what most idiots in the forums tell you to do, and that is to just plug a relay in and out and see if it clicks. If you already think that that's idiotic, good for you. If you don't understand why that is a really swaptronics method, it'll become blatantly clear to you in this video. But what we're going to do is not only show you some basics with relay testing and stuff, but you will also find that this is going to be very applicable to you improving your efficiency with testing many electrical components and systems, because of the accessibility of most relays easily found in the engine bay of a car. So we'll get into that a little bit and how you would take advantage of this. So let's start off with reviewing what relays are so everybody's on the same page, and then we'll see if I end up frying my electrical system in this process, which I don't think is going to happen, but I know most of the electrical engineers that watch this program are dying to see me do that. I do know enough about electricity not to do major damage, and I will also tell you how you can prevent doing any damage if you want to start experimenting with this and stepping outside of your comfort zone. So let's see what happens. So most of you guys are well familiar with this. This is just your standard relay. And the thing is, despite my not having any formal electrical training, or really actually any electrical training at all, and a very weak electrical background, given the basic knowledge that I do have, the knowledge that I'm going to show you, if you're not familiar with it, is actually going to get you pretty far. It really will. So let's look at this basic relay here, which normally has even a simple electrical diagram on it, but this one actually does not. So I have no idea what these contacts are, but because of my understanding of the basic operation of a relay, I'm going to be able to figure it out without using a wiring diagram. Pretty much you've seen in every video, I don't tend to use wiring diagrams a lot. It's not that I can't read them. I love wiring diagrams. They make it easy. It's just two things. First of all, usually, because I have to find wiring diagrams on the internet, you get 50 million different wiring diagrams for the same car and model year, and I have no idea which one is accurate. And the second thing is, to be honest with you, it usually takes me longer to find a wiring diagram than it does to actually just figure out most simple circuitry myself. And that's actually what we're going to do today. So let's, again, this is going to assume that you know how to use a voltmeter, you know basic automotive electrical. If you don't, there's thousands of videos out there that you can watch that will explain that. There's also thousands of videos that talk about relays, but I don't think they're going to do it exactly with the goal that I'm going to do a little bit later on, so just keep that in mind. But let's go ahead and draw a relay up here. So basically, a relay is just an electromagnetic switch. That's all it is. It's just a switch. And basically, the way it works is by putting current through the electromagnet, this magnetic field is going to pull up on this switch, so that when that switch makes contact, you get continuity and current flowing through this actual switch. And that's all that it does. So obviously there is going to be some way that you are going to complete the circuit on the electromagnetic side, or the control side. Typically there will be either a switch here, maybe it'll be your headlight switch, your horn switch, something like that. It could also, of course, be positive side switched. You could have a switch here, but the bottom line is some kind of switch if it's activated, is going to create continuity in the circuit, activate that magnet, and then pull up that switch to close it, completing the main objective or the load circuit. So obviously one of the questions is, why would you want to do that? Why not just have a switch here and not use a relay and just have the wiring go straight through? Well, there's a few reasons why you might want to use this sort of secondary switching system as opposed to a direct switch. One reason is, using this relay, you're able to take advantage of the fact that you can have a very high current on your load, but use a very low current in the control side. A great example of this is in your home HVAC system. If you've ever wired your own thermostat, have you ever noticed that your thermostat wires are extremely minuscule, but you look in the fan motor or the heater or something like that, and you got 220 volts going through there with these massive thick wires. What an advantage it is to be able to use very, very thin, low current wiring in your thermostat, but then have that control a relay where in the actual meat and potatoes of your HVAC system, you've got these high current, heavy gauge wires that are running through. So that's an example. In typical automotive applications, relays can be used for a couple reasons. One of them is for high amperage devices. You can get away with using less bulky, less beefier switches. The other thing too is sometimes it's advantageous to use a system like this because you can borrow off of the control system to then run other relays and other electrical systems, so that this electrical system is dependent upon this system being turned on. A good example of that might be, I don't know, like if this controls your headlights, so you have your headlights on, then that may draw another relay to come into action to turn on, say, the interior dashboard lights or something like that. This way your dashboard lights and your control panel lights and your radio lights and everything could be on their own 12-volt circuit separate from your headlight circuit, but that circuit would only be active when your headlights are on. That way you wouldn't have to remember to turn your control panel lights off when you turn your headlights off. But there's all kinds of reasons why you would want to use relays like that. But in general, it's usually because you want to use a low amperage switch to control a higher amperage load. Now remember, it's very important, if we look at this diagram, that without using a wiring diagram, we're going to be able to map this guy here very easily, because we can see that on the control side, there is going to be a continuity here. And we can also see that on the load side, where the switch actually is, there is not going to be continuity unless we put electricity through the electromagnet. So without even knowing which is what on this thing, because there's no diagram, let's see if we can figure out the map in this actual relay. All right, so let's look at this relay, and as shown in the diagram, there are 4 contacts. 2 of these contacts are going to be for that electromagnet, and the other 2 contacts are going to be a switch. Now, there's no diagram on this. Typically, there's a diagram on these, but without using a wiring diagram, we're going to be able to figure this out. Obviously, if we get continuity, we know we are on the control side. So here we see this is going to be the switch side. The switch is open. We have no continuity here. So that means that these silver contacts have to be where the electromagnet is, that if we were to put electricity through, it would close the switch between the copper contacts. So if we look here, we see there we have continuity. So from what we understand, if we were to put 12 volts through these contacts and activate the magnet, that should close the switch in the relay. We should, of course, hear it click, but that doesn't necessitate that we have continuity then between our contacts. So let's go ahead and just test our theory real quick here. what I've got here is a tool called a power probe, and don't be intimidated by this. All this is it's just a jumper wire. This is the negative and this is the positive. This just makes it a little bit safer and easier because I don't have it live unless I actually press the button here. But all this is, you can just use any wiring, a negative from the battery and a positive from the battery. That's all this is, so don't be intimidated. Here, I'll even just turn it upside down so it just looks like a positive and a negative wire. And what we're going to do is go ahead, and the polarity of course won't matter here. And when I touch the positive, we should hear a click. See if you can hear that. Okay, so that's good. Obviously, if we were to switch this around, it's not going to do any damage. There's just not going to be any continuity there. It's just going to be an open switch. So if I do it now, nothing happens. There's just an open switch there. But when we add electricity through that electromagnet and it closes the switch, that is going to cause continuity between these contacts. So we can hear the switch closing, but let's go ahead and prove that we have continuity when we do that. So let's hook up our voltmeter. All right, so I'm just going to look for continuity here, and obviously, let's see if we can get that all in the shot. That looks good. So we can see that we, of course, have the switch open. As soon as I put 12 volts, we can see that we get continuity on the meter because the switch is closing. So we know that that relay is working and that when the switch closes, we do have continuity between the terminals. All right, so that was basic enough. I think everybody follows that. We put 12 volts through the electromagnet, which of course pulled the switch up to create contact. We confirm that contact by measuring that there was continuity between each of these ends, and that when we removed the voltage, the electromagnetic field stops, the switch is open, and we lose our continuity that we tested at the meter. So very simple operation. Now, do you see why it is very important that you not test a relay the way that the asshats at those forums and chat rooms do? God, I love those forums and chat rooms. What they're going to tell you to do is to just simply plug the relay into the outlet in the car and listen for if it clicks or not. Do you see that there are multiple variables that would explain why the relay won't click? First of all, what if there is no power coming in, either because there is some switch here that has to be activated, maybe a headlight switch or something, or what if there is just simply a wiring problem where there is no power to activate the electromagnet? In that case, the relay may be perfectly fine, but no combination of what you do is going to cause that relay to click in that socket because there is no activation of the electromagnetic current if there is no wiring integrity. So that is just one example of how that would happen. Do you also see that you may have an open ground? It is possible for a number of reasons. You may have a switch here that actually works by, this would be hot at all times, or maybe hot with the key on, who knows. But when you activate this switch, it closes the ground. So it's a ground side switch. Do you see if you have a bad switch, even activating that switch, plugging the relay in or out, may not cause the relay to click if the switch is bad and it doesn't close the ground. It's also possible the switch could be good, but you have an open to ground after the switch. There are many possible reasons why a relay may not click just by plugging it in and out of the socket. So it's terrible advice, but typical of what you'll get from the people on those chat rooms and Yahoo Answers and everything. Thus the reason for my channel. It's my losing battle against people like that that give advice when they have no concept of actual application. Do you also see that it is possible that you could have this relay click, but not necessarily have contact with the switch? So in other words, the electromagnetic part works. You get the switch pulling up, but it still may possibly not be making contact. Thus the reason why I did the ohm test to ensure there was continuity on the switches when I activated the relay. So do you see that there are possibilities where you can definitely have a good relay even if it doesn't click when you insert it in the socket, and you may have a bad relay even if it does click. So it's very important to understand that so that you diagnose the right thing. So let's try something new here. This relay that I pulled out is for the horn circuit, and it lives right here. Based on the testing that we just did, we can now tell some things about this circuitry here. First of all, we've already determined that these copper contacts are the switch or the load side. So those are the side that is going to actually operate the switch to activate the horn, supposedly. And these contacts, the silver ones, are the actual electromagnetic control side that closes the switch for the horn. So let's see if we can map out this circuit if we were going to do some troubleshooting based on the fact that we understand how this relay works. Now this relay only goes one way, so we know that these contacts here are going to be the switch side, and the contacts up here, these two, are going to be the control side. So if we look at a diagram of the socket here, then obviously looking at this, we don't know anything except these two. This is the front of the vehicle. These two are the control side, and these two are the load side, but we don't know anything else. So what I'm going to do is just use my voltmeter and look for voltage using these probes in the control side. And I can see that there is no continuity in the control side of the circuit. So what would that tell me? Well, one thing it would tell me is that obviously there needs to be some type of switch, and in this case I would imagine it would be the horn switch that would cause the continuity to occur. And it is also possible, of course, that there could be a problem with this circuit. But let's see if we can get continuity if I actually push the horn button, and let's make sure that meter is in play there. So I'm going to go ahead and push the horn button, and let's see if we get continuity. All right, hopefully that won't be too much of a glare, but let's go ahead. So I'm going to go ahead and push the horn and let it go, and push the horn and let it go. So as we can see, pushing the horn button, of course, didn't cause the horn to sound because, of course, the relay isn't in place, so there was no switch there. But we can see pushing the horn button does activate that electromagnetic switch in the relay. So when you hit the horn button, the electromagnetic switch operates. Now, the question is that a positive or is that a negative side switch? I'm going to go ahead and take this probe out, and let's get our meter in play there. Make sure we're looking at voltage. And what I'm going to do is I'm going to go ahead and put this to ground, and let's see what happens. When I put it to ground, we get 13 volts. So what does this tell us? Well, there's no keys in the ignition or anything. So that tells us that this particular outlet right here for the control circuit is hot at all times. We know that that circuit is hot at all times, whether there is a key in the car or not. So what do we know about how the horn works? The horn is actually a ground side switch. When you press the horn button, you are completing a ground from the relay to the battery, and that is going to activate that electromagnetic switch, which then means that these two contacts activates the horn. Now, after doing the polarity testing here, we know which one of these outlets is hot, and we also know that it is hot at all times because there was no key in the ignition. So this we know if the relay were plugged in, that would be the flow for our control. So now, as a result of seeing the continuity when we press the horn button, one thing we know is that the horn switch This, of course, would be your ground here. This here is your horn switch. The horn switch works by, of course, closing to complete the ground on the control side. That is how the horn switch works. Once that happens, we of course know if the relay were plugged in, we would close the gap here using the switch inside the relay. So let's see what the polarity is on those. So let's go ahead and look at the voltage on the load side now. All right, so what I'm going to do, and again, I'm just totally guessing here. I'm going to go ahead and put my positive on the load side here, and I'm going to put my negative here. And we can see that we are reading 12 volts right now. So what does that tell us? Well, that tells us that and also notice my polarity is correct. Let me just reverse that just to make sure. Yes, so we know that this load side of the circuit is also hot at all times. And we can see that we have a good ground. So this would be important to know. If we didn't see any voltage there, then we would know that we have either an open ground or an open hot. We would easily be able to test that. Let's go ahead and test this to ground. So I'm just going to put this to any ground, and we see we have 12 volts. And the other thing I could do, I'm going to set my meter to continuity. And let's go ahead and see that we have continuity at the ground. And you can see we do. Now, what does this tell us? Well, this tells us that if we were to make a connection between these two contacts, in other words, if we were to act as the relay and close that switch, the horn should sound. So let's go ahead and try that real quick. And ideally, it would be smart to use a fused wire, but I'm pretty confident that I've got this right. One thing you don't want to do, you obviously, if you have even a basic minimal knowledge of electricity, you can see where you can easily do some severe damage here if you were to jumper directly from positive to negative with no load in between. Now, obviously, that's not a danger in this situation because we've already determined the horn switch must be pressed in order for the control side to be complete. But if that were not the case, then you could definitely, you would not want to jumper those wires on the control side if that horn button were already closed, because you would be going through no load and you might do some damage. But if I go ahead and close this switch, we should hit the horn. Just like that. Excellent. So what we've determined is that this side here is hot at all times, and we know that this side here is grounded at all times. So we know pressing the horn is going to cause the completion of the circuit through the electromagnetic switch, which of course is going to allow the continuity through here. Now, the one thing that we actually don't know is the actual location of the horn. Is the horn located here, or is the horn located here? And most likely, I'm guessing it's going to be on the ground side. Well, that's very easy to test. If we were to put 12 volts through here, through the ground side, and we hear the horn, then we know that the horn must be wired in on the ground side. And I am pretty confident that it is. As a matter of fact, so much so that we're just going to go ahead and try that. So if we remember, these are the control side, and this was the load side. We've determined that this here, this terminal here, is hot at all times. That's the power side, so this is the ground side. So therefore, if I were to put 12 volts to this ground side, that should sound the horn if the horn is on the ground side. All right. All right, so the nice thing about this is with an extremely minimal amount of electrical knowledge and very minimal tools, really just a DVOM and also a jumper wire and pretty much Pretty much that's it. You don't even need that fancy power probe tool like I had. All you need is just wire from positive and wire from negative from the battery. So very basic tools. And we can now very accurately map out the horn circuit on that automobile. So we can start off with the relay. And we know we have a switch that is normally open. We know that there is a positive hot at all times. We know for a fact that the horn switch is a ground side switch. We've determined that. We also know that this is going to go to the actual horn, which of course is going to be grounded. And we also know that this goes to a hot at all times. So using just very basic minimal skill, we were able to map this circuit out, and you can easily see that it really wasn't that difficult just using some common sense. One thing I do want to do though, let's just verify 100% that we're accurate, but there really is no other possibility. There's no other possibility than that this is an actual representation of the horn circuit. But let me just look up a wiring diagram just to be sure. Okay, and I found a similar diagram, maybe not the exact one for that car, but as we can see, we've got our relay here. We see we're hot at all times. And we also have, of course, on the other side of the relay, our switch. When we follow the switch, we see that the horn is on the ground side here. And then we also see that the horn switch completes the ground from the control side of the relay. So we did map it out correctly. All right, awesome. But was that just pure science, or is there actually some application to this while I go ahead, because I am done listening to that horn? And the fact is, there is actually some practical application to this, and it just happened to be this weekend. It's one of the reasons why I decided to do this video. So let me go ahead and explain that to you real quick. So this weekend, I was diagnosing a headlight problem on a car. And the problem is the owner stated that both headlights did not work. And he actually already bought 2 new headlights, of course, but he couldn't figure out how to install them. This was, I forgot, it was like a Saab or something like that. And it was very difficult to access the headlights. Obviously, with 2 headlights out, it raises a little suspicion. I guess he also didn't notice that his taillights didn't come on when he turns the headlights on. Very indicative that maybe his headlight switch isn't working, or maybe a blown fuse or something, rather than both headlights being out. But the point is, it was very difficult to access the headlights. A very typical thing that anybody would want to do, you would want to turn the headlights on, unplug the headlight socket, see if there's 12 volts at the socket, and then maybe even put 12 volts directly to the headlight, see if the headlight lights up. Well, on this particular model, it was very, very difficult to do that. It would have taken much longer to access the headlights, removing the ducting and the radiator covers and stuff like that. So what I decided to do was step a little bit outside of my comfort zone and try to take advantage of the headlight relay to see if I could verify that there was actual activity from the lighting system using the relay, as opposed to maybe guessing at the switch and taking apart the dashboard to take the switch out, because that, of course, also was equally unpalatable. So let me show you how I did that.